So we have the integral from 0 to 88 sine the square root of x dx, and with a given value of n, so we are told n equals 4. Approximate the integral. Run to the answer to 4 decimal places. Thank you. Okay, so remember how we do this. This is approximately delta x times f of x1 plus f of x4, where delta x would be 88 minus 0 divided by 4, which is 22. So 0 to 88 and 22 and 44 and 66. So the midpoint right here at 11, right here at 22 plus 11, which is 33, and then at 55, and then at 77. So then we have everything we need. So delta x 22, and I have to find f of 11 plus f of 33 plus f of 55 plus f of 77. Whatever that is. Oh, I'm sorry. I thought you were getting ready. Okay, so now let's plug it in. So what I would do is just write in parentheses so one option would be, and I was just thinking about it, let's put this function in, which is sine the square root of x. Make sure that the mode is in radian mode. Careful. So it is. Okay, so then we have 22. And in parentheses, call function y1 evaluated at 11 plus call function y1 evaluated at 22 plus call function y1, like we did with Newton's method, evaluated at 33. No, I'm sorry, the next one was 33. And then the next one is 55 and then 77. And then plus the last one, I call function y1, and at 77, close the parenthesis for the function and close the parenthesis for the whole thing. And I got 18.1200. They said 4 decimal places? 4? Yeah. So I got 18.1200. Good. Anything else? Is there anything else you would like to review? Yes? Yes, we can do the same thing with the list. Yes, let's do just that. Okay. So go to second and list. No, sorry. Just go to list, to stat. And then edit. So I'm going to edit the first list as the entries. 11, 33, 55, 77. 11, 33, 55, 77. Oops, 77. And then go highlight list L2 and just multiply 22 times list L1. Press enter. We will determine we will get all the answers at the same time. And something is not right. Oh, yeah, of course. Makes no sense. Okay, I forgot. Sorry about that. So it's 22 multiplied by sine of the square root of L1. And close the parenthesis. And now press enter. And all we have to do next is add those up. In order to add them up, one option would be to go to stats and calculate one variable stats, but this is on list L2 because all the information is in list L2, and just highlight and calculate. And we get the sum. Remember the notation, right? The summation, not the x squared, nothing else. The sum of x, 18.1200. So the answer must be the same, no matter what we do. In this particular situation, I thought of showing you the other way with just evaluating the function and adding the answers for 11, 33, 55. Is this okay? Better? Okay, perfect. Next question. Is there anything that we would like to continue with? Yes? So evaluate the upper. Okay, so what I have is f of x equals 2 plus sine x. The interval is 0 to pi, and they want 2, 4, and 8. Okay, so let's choose one. Let's choose which one you would like to use. The N2, 4, or 8. Because, okay, 4. Because you have to perform basically 2 calculations for each. The leftmost point with 2, the leftmost point with 4, the leftmost point with 8. But I wouldn't do that. So the leftmost point with 2 and the rightmost point with 2. The leftmost point with 4 and the rightmost point with 4. The leftmost point with 8 and the rightmost point with 8. So we want to look at 4. So n equals 4. So the first area will be pi minus 0 over 4. The left 4. With left 4, I have, let's divvy up first of all to see what's happening here. So we have the interval between 0 and pi. And we'll divide in 4. So this is pi over 2, and this is pi over 4, and this is 3 pi over 4. I said 4 and I wrote 8. Nobody knows why. Okay, so for the leftmost point, I would have to use f of 0 plus f of pi over 4 plus f of pi over 2 plus f of 3 pi over 4. For the right, which we'll calculate in a minute. For right 4, I will have pi over 4, or pi minus 0 over 4, but this time I have f of pi over 4 plus f of pi over 2 plus f of 3 pi over 4 plus f of pi. Done missing? Very good, thank you. See you. Happy Thanksgiving. Okay. So let's perform the operations again. Is this good enough, or you want us to perform the operations?
It's good enough for me.
We will apply the same one or the other. We either create the lists, but then we'll have to create several lists, one with 0, pi, and 2 lists. So.
What I didn't understand was when they asked for upper sum and lower sum.
Right, because for any function, either the leftmost point or the rightmost point would guarantee a max or a min, an upper limit, upper bound, and a lower bound. The middle one will always have to be between those two. So I'm just coming up with some numbers. We're going to calculate this. So let's say the first one is 5. let's say the second one is 2. This, the rightmost point, is the lower bound. The leftmost point is the upper bound. And if you use the midpoint, so in other words, you use this point and this point for the height, and this point for the height, and this point for the height, it will definitely be between those two. Between my example, silly example of 2 and 5. And it will be the closest to the real number for any number of subintervals. So since we talked about that, let's finalize it since it's up here. So one option, again, if you want to use lists, I will have to create 2 lists. So first I like to do that, so just make sure. Okay, so the first list will be 0, pi over 4, pi over 2, and 3 pi over 4. What is going on here? Okay, this software is not the best, I think. Okay, 0, then pi over 4, and then pi over 2, and then 3 pi divided by 4. That's the first list. Now the second list starts at pi over 4, and then pi over 2, and then 3 pi over 4, and then pi. Okay, the first one will be pi over 4, so in parentheses, pi divided by 4, close the parenthesis, and now the function is 2 plus sine of list L1. And then the second one for the second list, I mean list L4, this will be still pi over 4. Parentheses, please. Pi divided by 4, close the parenthesis and open, 2 plus sine of list L2, close and close. So now remember the first one, when I create the sum for L3, will be with the leftmost point. Okay, thank you. Happy Thanksgiving. So when we determine the sum for L3, that would be the leftmost point. When I determine the L4, it would be the rightmost point. Okay, so with get out of there and then stat and then calculate. I want one variable stats, but this time on list L3, which will be the leftmost point. And then the sum is 8.1793. 8.1793. Let me write that down. So for the first one, and for the other one, I will repeat, but this time I want list L4. And I get the sum to be, okay, did I mess up something? Okay. So I'm checking my numbers. 0, yes. Pi over 4, yes. 3 pi over 2, yes. 3 pi over they can be equal, so obviously I messed up something. Okay, 0. Pi divided by 4. pi divided by 2 and 3 pi over 4. Yes, 3 pi over 4. 3 pi divided by 4. Okay, so now these are all correct, and this is 3.14. Okay, so I'm going to calculate that. L3 again. Okay, so in parentheses, because that's delta x outside, pi divided by 4. Now, if you got something else, please tell me. So 2 plus, it's 2 plus sine x, right, sine of list L1, close the parenthesis and close the parenthesis. Okay. And for list L4, I want parentheses, pi divided by 4, and in parentheses, I want 2 plus sine of list L2, and close. They can be the same. They can't. They are not the same numbers. So I'm doing something here. Okay, let's do it again. So I want to calculate. I want one variable stats, and I want list L3. L3. Calculate for me, please. Okay. Is that one. Okay, so now I'm thinking for a second if it could be the same. So from 0 to pi, sine has a positive and a negative, right, piece. And then 2 will shift up everything. So if we use the leftmost point or the rightmost point, it's a symmetric graph. Okay. Okay, so it is possible. Let me see one more time. Let me redo that. Okay, the last one. So, and then I'm going to have to graph it because now I have to convince myself of this. List L4. Okay. List L4. Okay. Okay. Now we have to graph it. So we got the same thing as 8.1793. Okay. So the interval is between 0 and pi. So this is pi over 2 and this is pi. And the graph of the graph of sine, right? It's 1 at pi, and it's 0. It's 1 at pi over 2, and it's 0 at pi. Okay, I see. So if we shift this graph, because that's what 2 plus sine x is, right? So then the graph looks like this. So the area that we are looking for is this. Yes, it's a symmetric graph. It's a symmetric graph. So regardless of whether we start from the leftmost point or the rightmost point, so these will be the 4 subintervals. So the leftmost point will be this, and this. Very interesting. And leftmost point and this, and this. Now with the rightmost point, it's going to be this. So for that reason, the areas are the same. So for 4, it's the same thing. Very interesting. Thank you, Felix. They are the same. Say it again.
The decimal.
What did it say?
Oh, you put 8.18.
I did. The answer didn't come up.
So it didn't?
No, I wasn't gonna say.
But we have to see that.
It's.
So did you use 4? Use 4.
It's required, asked for 2, so it started with, I think it's, didn't like that kind of, probably like 20.
So it is 0, 5, and 4, 5, and 2, and 3, 5, and 4. That's correct. And it didn't like, so let's see how many decimal digits they want.
They want 2, so I won 1 7 and 1 8.
So they want illustrate the diagrams, okay, shown below. Round your answers to 2 decimal places.
I put 1 8, which.
So 8.18. It's very interesting. We have to get to the bottom of this. But is it clear why they should be the same? Because the whole thing is symmetric. I wasn't thinking about it before I graphed it. What happened?
818 fails and
So 8.18 it does not like. Okay.
Does it tell you to round? It doesn't.
so we kind of gone through a few iterations now, so. What'd you
Oh.
get?
So did we get it?
Yeah.
I'm going to look again and see. It's radian mode.
This one will be just all numbers.
So I don't see any situation here though. So 0, pi over 2, 0, pi over 4, pi over 2, and 3 pi over 4. Or from pi over 4, pi over 2, 3 pi over 4, and pi. So I multiplied, I did not forget the delta x. I had delta x in front, right? So that's pi over 4. And then in parentheses, I had 2 plus. Is that the function again? Did we copy the function correctly?
2 plus some.
Okay. So 2 plus sine. And it has to be applied to list L1, each and every one of them. And I get that number, all these numbers. And all those are delta x times f of x1, delta x plus times f of x2. And when I add them up, for list L3, I don't understand why.
I did this question too, but it's weird because it's the graph is weird. If you look at it.
So it's between 0 and pi.
It's like they asked for like this graph or maybe this is the correct graph.
But still, it doesn't matter.
And then this because like they do like the leftmost point and like look at
Right. Yeah.
Right up.
Yeah. It's this, there. It should be the same. So what is the question actually? What do you think is wrong? You may see something I don't, that I don't. So
Because like if you're doing like the leftmost point, it'd be this graph, but this is the correct graph.
yeah, the leftmost point.
Because if you look at the blue, is like leftmost point and rightmost
But
point.
I still have to use for 4 subintervals. We were looking at 4.
Yeah.
So I still have to find f of 0 and f of pi over 4 and f of pi over 2 and f of 3 pi over
Yeah, that's not the correct graph that said it. Just said it's this one for some reason. Which is fine.
But this is the rightmost one.
Yeah, this one here.
They calculated this area from the left, and they multiplied it by 2. Okay. That's what they did.
So then the uppermost point would be something different. Because it said
So-
8.96 and 7.9.
So what they did, they calculated this area, which is half of the area, right? And then they multiplied by 2. They did that because the function is increasing and then decreasing. That's why. I see.
Can you switch it to,
Oh, yes, of course. I'm sorry. So they calculated this area because the function is symmetric with respect to this line, this vertical line, right? So they calculated this area, just this. And then they said, forget it. Let's just multiply by 2. And then they've said, okay, don't worry about this one. Just multiply by 2 because they are symmetric. So I'm just curious now. But with the leftmost point, yeah, that's what they did. So in
it's okay. I was like, after I guessed it,
okay, so I'll clear this and I'll clear this. Taylor finished?
Yeah, as good as I'm gonna get.
Thanksgiving. See ya. Bye.
Well, about that CFR. Remember, I'm not gonna be here to have a ball in December.
Okay, so when are you trying to take the final then?
This Wednesday, you guys take with me.
Okay, so I'll send it to the testing center downstairs.
There's no way I can take it after the 21st.
We're closed.
Oh shit.
The whole thing is shut down.
Anytime after I get. That's what I'm trying to ask, because I'd rather not take it Wednesday if possible.
But we close on the. I have to turn in the grades on the 13th. Unless you send me something and you get an incomplete and you finish it up in January.
That's possible?
Yeah, if you send me something that I can attach to.
Okay, on that.
Okay,
Thank you.
so or we can talk on the phone. But
Yeah,
I need
can
something.
amend it, see how to send you
Okay,
the-
just send me something, yeah.
Thank you.
Okay, so let me try one more time. So we're interested then in this till 3, okay, and we multiply by 2. So it's 3.696953 multiplied by 2. In this case, so let's put in 3.7. Multiply, I mean 3.696953 multiplied by 2, because I only calculated one side. So 3.6969 times 2. So this is 7.3938. Which should be okay with 7.4. Right, but I don't disagree with what they did. But if we're using the leftmost point, we're using the leftmost point. But in a way, I see what they did, because they said, oh, okay, so it's symmetric, so let's not even bother with the other side, let's just calculate one side. So, but it was very interesting because we got the same thing with either side. And then we had to graph it. So That's why they show the graph. They show you the graphs first.
Yeah, sounds like
Because normally we don't really have to graph when we determine the leftmost point or the area, approximate area. Is this okay, Felix? Does it work? Well, as I said,
Next.
good. Next question. Is there anything from this test that we would like to
What was going to be on the upcoming test?
everything from chapter 5 plus 4.9? So as an example, again, I understand what they did, but I just would like us to discuss that something here that is. So here are some examples. So this is with 4 subintervals with the rightmost point, rightmost point, rightmost point, rightmost point. So even if the function is increasing or decreasing, you're not in the middle of a calculation. You're not going to stop and say, oh, all of a sudden, so it's symmetric. Let me multiply by 2. So so the rightmost point, rightmost point, rightmost point, rightmost point. Same thing here. They're all with the rightmost point, no matter what. I understand that this is a symmetric graph, and if you really want to have the best approximation, okay, fine. You're considering this, and you multiply by 2. Good. Very good example. That's why they give the graphs. Good. Anything else? Anything from chapter 5? Anything you'd like to go back to? Riemann sum, integrals, definite, indefinite, or we start reviewing for the final exam, and we go back now to the previous chapters, chapter 2, 3, and 4. I'm sorry?
Can you do some more Riemann sum?
Sure. So let's choose a function and an interval. And the function can be linear, quadratic, or cubic. We are not equipped for anything else.
Do you think we can do another trig function?
We cannot use a trig function with the limit of the Riemann sum. We don't have the summation for. We only have the sum of 1, the sum of I, the sum of I squared, and the sum of I cubed. We do not have the sum of sine I. We don't have any of that. We are limited to, oops, sorry. We are limited to these. We don't know what sum of sine I is, so we can't use it. Yes, I'm ready.
4x squared plus 4x.
A negative 2 to 0. Very good. Excellent. Okay, so let's determine the limit of the Riemann sum for this. Okay, so remember the 3 preps. The first one is delta x, which is 0 minus negative 2 divided by n, or 2 over n. B minus a divided by n. Then we have to determine xi. So how do I determine xi? Yes, negative 2 plus I delta x. Excellent. Negative 2 plus 2I over n. And now we have to find f of xi, which is f of negative 2 plus 2I over n. Good. Ready? What is happening here? Look at this. I got a cheat sheet here. Okay, so the function was 4x squared minus 4x or plus 4x, right? 4x squared plus 4x, correct. So 4, negative 2 plus 2I over n squared plus 4 times negative 2 plus 2I over n. Is this okay so far? So far so good? Okay, so now we have to square first. First term squared minus 2 times the first times the second plus the second term squared minus 8 and plus 8I over n. Is this okay?
I'm gonna have to take the 4 out of the
Yes, we can. I still have to put it all in because I have to find the sum of all those terms. So eventually I still have to. But yes, you're right, yes. Good, so now I still have to distribute and combine like terms if I can, and descending order. So plus 16I squared over n squared, and this is minus 32 plus 8 minus 24I over n, right? Negative 32, so this is 4 times 4 is 16, and it's the only term with I squared. And 4 times negative 8, negative 32, negative 32 plus 8, negative 24I, and then a plus 16 minus 8, which is plus 8. What we should have done from the very beginning is just determine and see the answer, to have the answer ahead of time. Not because we're trying to cheat, it was because just to see what we're to expect. We know the area will be from negative 2 to 0, from 4x squared plus 4x dx. So this is 4x cubed over 3 plus 4x squared over 2. Just took that out. From negative 2 to 0. So when I plug in 0, everything goes away. So then minus, when I plug in negative 2, negative 8/3, and 4 divided by 2 is positive 2. We know that the area must be positive because this is a positive function on this interval. Yes, it is. Okay, so negative 8, the least common denominator is 3. 3 here, negative 8 plus 6, negative 2. So the answer must be 8/3. So we expect the answer to be 8 over 3. And let's see if we get it and how we get it. Okay, so finally we can put everything together for the limit of the Riemann sum. We have all the pieces. Limit as n approaches infinity from the sum from I equals 1 through n. Delta x, 2 over n, I can already put it outside. I'm sorry. Now the sum of the first term, let me write it first because I already started. And now it's the limit, n approaches infinity 2 over n. So now 16 over n squared, the sum of I squared, minus 24 over n, the sum of I, plus 8, the sum of 1. from I equals 1 through n, from I equals 1 through n, from I equals 1 through n. Let's think for a moment and please tell me whether this is okay. Is this okay? Is that okay? So now we have to replace these three sigma notations or summation notations. The first one will be replaced with the ugly one, which is n plus 1 to n plus 1 over 6. The next one will be replaced with n plus 1 over 2, and the last one by n, or with n. Is this okay, everyone? Yes?
So for the I squared functions, bottom fraction, six.
Yeah, this one has 6 in the denominator, so it's n plus 1 to n plus 1.
Okay.
And this one is n plus 1 over 2, and this one is just n. Is this okay? So 2 over n, 16 over n squared times, I'm just replacing them now, inside, not outside as I wrote them. So minus 24 over n plus 1 over 2, n plus 8n. So in the next step, I just rewrote the whole thing without the sigma notation, replacing each piece by what it equals to. So now I'm trying to simplify. I will take away an n from here from the numerator with an n from the denominator. The least common denominator will still be 6, so I will not simplify anything here. There is no point. Because if I do simplify, I have a 3 and then a 2, so I still need 6n in the denominator. But I would take away one of the n's, which is this with this. So then limit n approaches infinity 2 over n, and the LCD is 6n. So for the first one, I will distribute these 2 and distribute 16. Here I have 2n, so I have to multiply by 3. And here I have 1, so I have to multiply by 6n. So this one gets multiplied by 6n. This is a 2n, so it needs to be multiplied by 3. Okay, ready? And this, we know, is 2n squared plus 3n plus 1. So I'm distributing 16. 32n squared plus 48n plus 16 minus 3 times 24. I think it's 72, isn't it? Okay, so 72 with minus and n squared. And minus, oops, 72n squared and minus 72n. And finally plus 48n squared. It's here.
That's 72.
Yes, I'm sorry, I wrote 7 by mistake. Yes, it's 72n squared minus 72n. And now we combine like terms. So this is limit n approaches infinity. Now the denominator is 6n squared. So 32 and 48 is 80. 80 minus 72 is 8. 49 minus 72 is negative, is it negative 24? N. And then plus 16. I will simplify. And I do get 8/3. Let's say we don't see that. It's infinity over infinity. So this is limit as n approaches infinity from 16n minus 24 divided by 6n. And when you differentiate again, because it's infinity over infinity, you get 16 over 6 or 8 over 3 as expected. Any questions?
Test rehash it this way, not the other.
You have to do both, of course. You will have many definite and indefinite integrals, but you also have one example with the limit of the Riemann sum. Yes. Good.
Rational functions.
Say it again. I mean, for we are only restricted to linear, quadratic, cubic.
Like factors out.
We cannot determine the I, the sum of. We don't have that information. No. You can only determine. The sum of 1, the sum of I, the sum of I squared, the sum of I cubed. We don't have any other information. Good. Anything else? We know how to determine the area from a graph. We know how to determine the limit of the Riemann sum. We know definite integrals, indefinite integrals. We know how to find the area given a table. We did that last time also. I'm sure I looked at the examples from WebAssign. What else can you think of? Anything else that you can think of for this test? I don't want to waste time.
You said flanking in the area for the table.
Yeah, we did that. The same thing, the leftmost point, rightmost point. Yep, exactly the same thing. Or we can look at another. So we just looked at this. So we found the leftmost point and the rightmost point.
Can we practice doing the middle?
But not with this. You don't have the function. With the midpoint, we just did the midpoint. This was no, not today actually. Yeah. This was sorry. Yes, we just did a midpoint. That's what I thought. And I said, oh, where is it? So, is there anything else that you would like to review for this test? Because after the test, we only have one more session before the final exam. So, I'd like to go back and review. So, let's go back in time. So, let's see what we have. So, for test 3, we had optimization problems. Let me bring that test up because we have solutions here. But of course, if you think of something else for this test coming up, so stop me and say, I remember one thing, let's do it, and we'll do it. Okay, so let's take a look. And you'll tell me what, the total distance, don't forget, very simple integrals, fundamental theorem of calculus part 1, midpoint rule again. That's it, really. Okay, so let's take a look. So here we were asked to determine local max, local min, one type of problem. Here find the critical numbers. Remember they come from two sources. This was to study a function on a closed interval. Mean value theorem. Use the graph to identify when it's opening upward and when it's opening downward. So what happens, where is the maximum increase of a function or the maximum rate of change of a function? Is when we determine the second derivative when it's not equal to 0, right? So we are trying to find the maxima or maximum of the first derivative. That is when the rate of change is maximum. Okay, so here is the rate of change maximum where the first derivative, right? So this is the function, right? The first derivative. So the function opens up and then down all the time. So up between 0 and 2 and down between 2 and 6. So at this point, it has a maximum, max, min, min, which means the first derivative is 0 or undefined. Here the first derivative is undefined, but it's still a critical number because the function exists there. The derivative does not. But since the function is defined, this is in this case, it's not just a local min, but it's an absolute min. And there is no absolute max, unless we consider absolute max, but this is not what the problem is asking us to determine. Find the intervals of increasing and decreasing, intervals of concave upward and downward, and the coordinates of the point of inflection. So it opens up and then down all the time. So this is the point of inflection, 2, 3. And this is where the derivative is maximum at the inflection point. Okay, the graph of the derivative is given. So if the derivative is negative and then positive, that is a minimum. If it's positive and then negative, that gives us a maximum. Okay, so this is the situation. So the same idea. So we have a function, and I said it increases slowly and then speeds up approaching x equals 8, of course, then continues to increase, but slower and slower. So leveling off. So at 8, the rate of change is maximum, and that's where the inflection point. It's because it's not a straight line, but it's the maximum possible. It reaches, I'm just giving you a number, 10. 10 number of cells per hour. I'm just making up a number. That's the rate of change, is the maximum rate of change is here. And after 8 hours, assuming that maybe it starts, it's still increasing, but it slows down because it does not have unlimited space. So it has to slow down because it's slow. For example, let's say in here we can bring in 50 people, right? But then when we maximum, let's say 55, and then we can continue pushing them in, but it's not the rate of increasing the number of people will have to decrease and decrease because the space is limited. Right? So they are coming in faster and faster and faster. So we multiply at a very high rate, but then that's it, and then we can push another. That's what they do in Japan. I have not been, but I've seen it at underground. Because they have to shut the doors. I would not do that. So it's like in a limited habitat, right? In a limited habitat, you can push people in and increase, but then at some point in time you can't anymore, right? Okay, so then we looked at L'Hopital's rule and lots of limits here. Okay, this is still very fresh in your memory because it was just last week, right?
Can we go over to L'Hopital?
Yes, anything. Yeah, so L'Hopital will be the next. Being able to graph and understanding step by step how to proceed here and how to come up with a graph is very important. So that's another important topic. And then optimization, and then Newton's method, and then finding a slant asymptote. So we decided to go back to L'Hopital's rule. So let's look at L'Hopital's rule. This is section 4.4. There's 7 indeterminate cases. And now please choose whatever you want. These are all L'Hopital's rule or not, meaning if we have an easier method, use the easier method. If you don't have another method, use L'Hopital's rule. So on page 308, anything? Do I get to choose, or you want to choose? You can choose from the previous test. You can choose whatever you want.
Can you take this test one, the minus infinity, minus infinity one example?
Yes, of course. Are we talking about this one? No.
It was on the next page. First,
This one?
It ended up being minus infinity minus infinity plus the.
No.
Wasn't there one like that?
You mean this one? At the top, infinity minus 0 minus. E?
E8E.
Oh yeah, but that's not the situation.
It's not
No. So that's okay. So let's do that. Limit as x approaches 1. From 9x over x minus 1 minus 9 over natural log x. Okay. So even if you say it's infinity minus infinity, you can't. This is d and e, and this is d and e. You can't even say that. Okay. So before we even identify what type of this is, I have to find the least common denominator. And I have to multiply the top by natural log x. I would have, to tell you the truth, I would have taken 9 outside, but that's okay. So, and multiply this by x minus 1. Agreed? So I'm going to put 9 in front now. So this is x natural log x, and this is a minus x plus 1, because I took the 9 outside. Is this okay so far? Yes? Is this okay? So I have negative x plus 1. Now I check, and I see it's infinity over infinity, or 0 over 0. Let's check. So when x approaches 1, this is 0, this is 0, okay. So 1 minus 1 is 0, negative 1 plus 1 is 0. This is 0, and this is 0, okay. So it's 0 over 0. And this is 0, and this is natural log 1, which is 0. And it's done. So knowing that it's 0 over 0, now I apply L'Hopital's rule. So then, limit as x approaches 1. I'll keep the 9 outside. I differentiate the top, but this is a product, so you have to be very careful. X prime is 1 times natural log x plus x times natural log x prime, which is 1 over x, minus 1, and this is 0. Now, the denominator is also a product. Careful. The first function prime is 1 times natural log x plus the first function times natural log x prime. So x minus 1 over x. And I will separate it in a minute. So 9, limit as x approaches 1. This is x over x, which is 1, but 1 minus 1 is 0. So the numerator is just natural log x. Now the denominator is natural log x plus x over x, which is 1, minus 1 over x. Do not be tempted to simplify the natural log from the top with the natural log from the denominator. That would be a terrible mistake. I'm not saying you would do that, but I just want to just say it. Okay, so now I check again. The top is 0. The denominator is 1 minus 1, which is 0, and this is 0. Again, I have 0 over 0. I'm hoping that this is the last step. So let's see if that's the case. So 9, limit as x approaches 1, the top is 1 over x. This is 1 over x. This prime is 0. And this prime is positive 1 over x squared. It's all done because when x approaches 1, I have the 9 from outside. The numerator approaches 1, and the denominator approaches 2. When x approaches 1, this is 1, this is 1. 1 plus 1 is 2. The 9 is outside, and the limit is 9/2. Is this better?